Welcome to the second day of Section 3, which is Show a Quadrilateral is a Parallelogram. Today we're going to be using the 6 main properties of parallelograms to prove that a given quadrilateral is a parallelogram. So far we've done this only using one way, by showing that the opposite sides are parallel. We're also going to show 3 other methods today. Remember that there's 6 properties in total. Opposite sides are parallel. We're going to cover that one. Opposite sides are congruent. We're also going to cover that one. Opposite angles are congruent. We're not going to cover that property today. Consecutive angles are supplementary. Again, another important property, but we're not going to cover it in this video. Diagonals bisect each other, and then one pair of angles is both congruent and parallel, and that will also be covered. So starting with example 1, this is the way that we've, in the past, shown that a quadrilateral is a parallelogram. It says, use the theorem given to prove that the quadrilateral is a parallelogram. Organize your work neatly. So these problems involve quite a bit of work, so I need you to organize them in such a way that I can follow what you're doing. So theorem number 1 says, if both pairs of opposite sides are parallel, then it is a parallelogram. This is what we've done so far. We did it in the last video, we did it in the classwork. So the first thing that you're going to want to do is graph this quadrilateral. So take a few seconds and graph the 4 coordinates. Okay, so this is what you should be looking at. Now, this is definitely a quadrilateral. It has 4 sides. In order for it to be a parallelogram, the opposite sides have to be parallel. So I'm going to see is AB parallel to CD, and then also is BC parallel to AD. If both of these hold true, then the figure is a parallelogram. Now remember, opposite sides parallel means that their slopes are the same. So we're going to have to find 4 different slopes, the slopes of all 4 sides. So starting with the slope of AB, I'm going to do y subtract y, so 0 subtract 4, over x subtract x, 2 subtract 3. This ends up being negative 4 over negative 1. So the slope of AB is just 4. And again, the slope formula is y2 minus y1 over x2 minus x1. Then I'm going to have to find the slope of CD. So my y's in this case are 6 and 2. So I'm going to have 6 subtract 2 over negative 2 subtract negative 3. Be careful there, you're subtracting a negative. So this becomes 4 over positive 1, because subtracting a negative is like adding a positive. So the slope of CD is also 4. Remember that M stands for slope, it doesn't stand for measure, it just stands for slope. So my 2 sides are the same, so that means that yes, this one pair of opposite sides is parallel. I know that AB is parallel to CD. Right now, pause the video and you find the slopes of sides BC and AD. Good luck. Okay, you should have shown that the slope of BC is negative 2 over 5, and that the slope of AD is also negative 2 over 5. That's the same thing as 2 over negative 5. So if you got that, that's the same. So again, we have another pair of parallel sides. And the last thing that I'm going to ask you to do is you're going to have to write a sentence. I want to know why ABCD is a parallelogram. So in this case, I gave you the theorem, but on your classwork, I'm not going to give you the theorem. So we're going to say ABCD is a parallelogram because both pairs of opposite sides are parallel. Okay. Okay, and so that should have been a little bit of a review to get our mind moving a little bit. We've already done that theorem before, so now we have 3 more. When you come to class tomorrow, I am going to be expecting to see the work for this entire problem. That means I'm going to expect to see the work for the slopes of BC and AD. So don't think that you can just skip ahead and leave that blank. Make sure you have that completed. Let's look at our second theorem. It says if the diagonals bisect each other, then it is a parallelogram. So first thing that I'm going to do is I'm going to plot these points, so you should do the same. Okay, so in this case, we could show that the opposite sides are parallel. That would definitely be one way to do it. But I'm telling you specifically that you have to show that the diagonals bisect each other. Diagonals bisect each other means that they share the same midpoint. So if we draw in this diagonal, they should intersect at each other's midpoint. So we're going to have to find the midpoint of both. So we're going to have to find the midpoint of AC, and we're also going to have to find the midpoint of BD. Okay, remember midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. Hopefully you remembered that. That should be a review. We're going to start by finding the midpoint of AC. So I'm going to take my x's, -3 add -7 and divide by 2, and then my y's, 0 add -6 divided by 2. -3 add -7 is -10. 0 plus -6 is just -6. So the midpoint of AC is -5, -3. Right now, I would like you to pause the video and find the midpoint of BD as well. Good luck. Okay, as you probably would have guessed, you should have found the midpoint to be -5, -3. If you didn't get that, my guess is that you maybe subtracted instead of added, or you made some mistake along the way. So make sure you have the correct work. And now we're going to write our final sentence. So in this case, we're going to say ABCD is a parallelogram because the diagonals bisect each other. So that's another way of proving that a quadrilateral is a parallelogram. Again, you should have all the work to show that the midpoint of BD is -5, -3. So we have 2 more theorems. If you would flip the page, please. Okay, so our next theorem says, if both pairs of opposite sides are congruent, then it is a parallelogram. As you can probably guess, we're going to start by graphing these 4 points. One thing I would like to point out before you start graphing is that point D should be -1, -5. Sorry. So make sure you graph that one correctly. Okay, so both pairs of opposite sides are congruent, then it is a parallelogram. This is going to use the distance formula. Let's see if we remember this. It's going to be x1 minus x2 squared plus y1 minus y2 squared, and it's the whole square root of that. So I'm going to have to find the distance between AB and CD, and those should be the same. And then I'm also going to have to do BC and AD, and those should be the same. So yes, I'm going to have to do the distance formula 4 times. No whining, it's not that bad. Let's start with AB. So my x's are -4 and 1, so I'm going to have -4 subtract 1 squared plus 1 minus 2 squared. Those are my y's. -4 subtract 1 is -5. -5 squared is going to be 25. 1 subtract 2 is 1. 1 squared is 1. So this becomes the square root of 26. Okay, and now for CD. I'm going to have 4 subtract -1 squared, and then I'm going to have -4 subtract -5 squared. -4 subtract -1 is 5. 5 squared is 25. -4 subtract -5. Remember, that's like adding, so that's 1, because 1 squared is 1. So that ends up being root 26 again. So what we've done right here is we've shown that AB is congruent to CD. Now I have one more pair of sides to do. So I'm going to do BC. So my x's are 1 and 4, so 1 subtract 4. And then my y's are 2 and -4. And remember that you're subtracting. 1 subtract 4 is -3. -3 squared is +9, so be careful putting this in the calculator. 2 subtract -4 is 6. 6 squared is 36. So this becomes the square root of 45. Now, this can be simplified, but you don't have to simplify it. Just leave it like that. And then last one we have to do is CD. Oh, sorry, this should be AD. AD. So it's going to be -4 subtract -1 squared, and then 1 subtract -5 squared. Remember that you can flip the order of the x's and the y's if you want to do it in a different order than me. That's fine, you should still get the right answer. So -4 subtract -1, that becomes -3. -3 squared is 9. 1 subtract -5 is 6. 6 squared is 36. So this also becomes the square root of 45, which is what we wanted. So this showed that BC is congruent to AD. So now we can say ABCD is a parallelogram because both pairs of opposite sides are congruent. So we need to write that. Okay, so we have one more theorem. It says if one pair of opposite sides is both parallel and congruent, then it is a parallelogram. So let's start by plotting our points. Okay, so what you're going to have to do is you're going to have to pick one pair of sides. Your options are one pair of opposite sides, A, B, and C, D, or A, D, and B, C. Pick one of them. First, you're going to have to show that the sides are parallel, which we did in example 1. That means that they have the same slope. Then, you're going to have to show that the same pair of sides is congruent. So you're going to use the distance formula like we did in example 3. So pick one pair of sides and stick with them. When you come to class tomorrow, I'm expecting this example to be finished. I want you to try your best. Pick either A, B, and C, D, or A, D, and B, C. Whichever pair you don't pick, you don't use at all. You're going to have to use the slope formula twice, the distance formula twice. And then I would like a sentence stating ABCD is a parallelogram because, and the reason. Good luck. Again, in this video, we learned 4 ways to show that a quadrilateral is a parallelogram. When you come to class, we're going to be doing more examples like this. I am not going to tell you which theorem you have to use, but now you've seen some options and you can pick the one that you like best. Again, example 4 needs to be completed when you come to class. Good luck.